In this experiment, we are going to look at the response of a truss. We are going to look at the measured forces in each of the members of a truss and compare it with the analytical values of the forces in each of these members. So, what is a truss? A truss is a structure composed of slender elements joined together at their ends with pins. We make two main assumptions in the analysis of trusses. The first one is that all the joints are assumed to be smooth pins, which means there is no transfer of moments. And the second assumption is that all the loads are applied at the joints. So what we are going to do in this experiment is apply a load and then measure the values of strain in each of the members. From the values of strain, we can infer the stresses, because stress and strain are related with the modulus of elasticity. Once you have the stresses, you can calculate the axial force in each member. So, based on the assumptions we are making, each member would be subjected to either tension or compression, which means that the force acting on the member is along the axis of the member itself. So that's how you would get the measured force in each member corresponding to the load applied using this device. Okay, so the way it works is explained in the video following this. You are going to assume that the load applied to the transverse member here, connecting these two frames in parallel, and you would have to assume that this applied load is distributed equally to each of the two frames or to the joint of each of the two trusses. And once you know the value of the force at the joint, you can calculate the theoretical forces in all of the members. And when you apply the load, you would also record the strains in all the members. And the goal of this experiment is for you to compare the calculated values for the applied load with the values inferred from the measured strains.
This is experiment 2, response of a truss frame. This truss has 13 members. This is the load applying apparatus and the load cell. Note, you apply downward load by turning the knob clockwise. All data and readings from load cell and strain gauges are transmitted to the data logger. Then the data logger sends the data to TC32K. All data and readings come to the data logger. These three knobs are used to control the data. This knob can be set to 120 ohm and 350 ohm. This knob can be set to 2G or 4G. This knob can be set from 0 to 13. The data from the data logger and the load cell can be displayed on the TC32K. Make sure the load cell is set to full bridge mode, 4G and 350 ohm. The load applying apparatus will be used on point A, B, and C. Note, you apply downward load by turning the knob clockwise. The load applying apparatus should be in a straight vertical line with member 3. Set this knob to 350 ohms. Set this knob to 4G. Set this knob to 0 and note the reading. Next, to find the strain from members, set this knob to 120 ohms, this knob to 4G, and by turning this knob from 1 to 13, you can read the data from strain gauges on TC32K. Reset the knob to 0 and set this knob to 350 ohms and this one to 4G. Apply a downward force of 10 kg. You should see a difference of 50 on the TC32K. To find the strain on the 13 members, set the data logger. This knob must be set to 120 ohms, this one to 2G, and turn the knob from 1 to 13 to find out the strain of each member. Next, increase the downward force to 20 kg. Repeat the process of finding the strain on each member. Increase the load to 30 kilograms and repeat the same process. Unload the load apparatus by turning the knob counterclockwise and move it to point B. Make sure it lines up vertically with the member 7. Repeat the same process by adding downward load of 10, 20, and 30 kilograms. Note the value of the strain gauges using TC32K. Next, move the load apparatus to point C. Repeat the process. When finished with the experiment, unload the testing apparatus.